Hi, this is Bill Punch from Michigan State University. Another video in the series of videos, The Practice of Computing Using Python CSE 231. Today we're going to talk about some more standard methods with the class hierarchy in Python and show us how we can do addition and subtraction with our own classes. Let's go ahead and get started. So we have talked about what it means to do encapsulation and why encapsulation is a really good idea. Things like hide details from the programmer and make them nice and portable, provide an interface for the programmer who will use the class in the sense of the methods. Now we want to add one more idea to making good classes, and that is we want to be consistent. And consistent really has two parts. We want to be consistent with the rules and syntax of the language. We want our classes to fit in with the rules, and we want our class to be able to respond to standard methods, methods that people who use Python expect would be there and could be able to use. We have a class that we made called the rational class or a fraction class. We're going to import that. The import process here is kind of interesting. We haven't done this before. From the rational file, import star, which means that we're going to import all the elements from the rational package into the main namespace. That's something that we typically don't do because we like to keep namespaces separate, but to make it easier to type some of these things, we did it this way. Here's what we're going to do, and here's the kind of fit in we'd like to have. We make a rational, two of them actually, with a constructor. We should be able to add two rationals using the plus sign. We should be able to use the difference of two rationals with the minus sign. And we should be able to print those rationals so that they look pretty nice. And we should be able to measure the equality of two rationals to see if the same number exists. So we're using the standard operators, but we're using it with a new class, and we want to make sure that when we do this, these things fit in. And if we run this, you'll see that, in fact, all of those things work as they're expected. The question is, how can we write this class so that we can get these operators to work for us? We're going to take a little side trip here before we get on, and we're going to talk about the idea of introspection. Before we make our class behave in a standard way, we have to remember what it means to have an overloaded operator. An overloaded operator means that when we perform an operation like plus, we need to look at the types of the two elements on either side. That helps us make a decision as to what operation to perform. 1 plus 2 is addition. Hi and mom are string concatenations. And so the two types taken together with the operator tell us which operator to perform. How can Python know the type of any particular variable so it can make this kind of decision? And there's two functions that allow us to do this. One's called the type function. It prints out the type of any particular variable. The other is called the isInstance function. It takes a variable and a particular type and returns a true or false, saying whether that variable is of that type. So my string is a string, my integer is an integer. Is my int an example of an integer? It is. Is my string an example of an integer? It is not. How can we use introspection, looking into the value of a variable's type to make a decision to do different operations? Here's a really simple example. We're going to write a special function called the overloaded function. And depending on the types of the two parameters, we'll have it perform one operation or another. The first operation that it could perform is that if the types of the two parameters are both integers, and I used both of those functions, the type and the isInstance, to show it off, what we're going to return is a tuple by the comma operator, the integral part of the division and the remainder part of the division. If otherwise, what we're going to do is we're going to try to convert both of those two parameters to floats, and if that works, create a tuple, return the float part and a none. We want the tuples to always come out, and so if the tuple has no remainder part, we give it a remainder value of none. And if it's not possible to convert these two parameters to floats, we're going to have an exception error and return two nones. Let's go ahead and define that. And then let's run it with 1, 2, 1 and 2.0, and A and B. So 1 divided by 2 is an integral part of 0, remainder of 1. 1 divided by 2.0, a float, gives me 0.5 with no remainder. And if I give it weird arguments, it returns none and none. So we are able to look at the types of the variables we send in and make decisions as to what we want to do based on that type. We're going to use that later, so keep that in mind.